Welcome to BTEC Revision. In today's lesson, we're looking at trigonometric ratios and graphs. By the end, we will be able to calculate the ratios of triangles using sine, cosine, and tangent rules, and interpret sine, cosine, and tangent graphs. Would there be a pattern when calculating the ratios of the triangle's sides? Let's start by labeling the triangle. Here we have the Greek letter called theta, and this is measuring the angle. Opposite the angle, we have the side called opposite. This can be abbreviated to the letter O. Next to the angle, we have the shorter side, that's called the adjacent. And this can be abbreviated to the letter A. The longest side next to the angle here is called the hypotenuse. And this can be abbreviated to H. These ratios are called trigonometric ratios. First ratio is sine theta. We can write that in short form as sin instead of sine, and this is equal to opposite divided by hypotenuse. The second is cosine, or cos for short, theta, and that's equal to adjacent divided by hypotenuse. The third is tangent, or tan for short, and that's equal to opposite divided by adjacent. We can use SOHCAHTOA, which is a mnemonic for remembering these ratios, where SO stands for sine theta is equal to opposite over hypotenuse. Ka stands for cos theta equals adjacent divided by hypotenuse. And lastly, we can take TOA to be tangent or tan theta is equal to opposite divided by adjacent. To work out the angle of the triangle, we need to learn about inverse functions. The inverse of sine can be written as sine to the power of -1. There's another name for this, which is called arc sine. Inverse sine of sine theta is equal to theta. And the inverse cos of cos theta is equal to theta. And the same with tan inverse of tan theta is equal to theta. So to find the angles, we can take the inverse. So we'll start with sine. So inverse sine of sine theta, it must be equal to inverse sine of opposite over hypotenuse. Because the left side is inverse sine, so therefore on the right hand side of the equation we have to inverse sine. Therefore these cancel out and we're left with theta equals inverse sine of opposite over hypotenuse. The first way to write this is if we take cosine, we'll take the inverse of cosine, which cancels out. So therefore we're left with theta is equal to inverse cosine of everything on the right hand side, which is adjacent over hypotenuse. And for tan, we can write that as inverse tan opposite over adjacent. So using these three equations, we can work out the angle of the triangle, depending upon which side of the triangle we have. Now pause the video here and attempt these questions. One very important thing to note here is that the angle needs to be set in the calculator. For question 1, we can see we have a unit of degrees. So you need to make sure we have degrees in the calculator. And we can do that by pressing the setup. And going into setup, we can see we have the choice of an angle. So it's called angle unit. And then you can choose between degrees and radians. So for question 1, we will choose degrees. Now, we can write sine 10 degrees in a calculator, and we just write that as sine 10. And that will give us a value of 0.17 to two significant figures. For cosine 10 degrees, that's going to be 0.98 to two significant figures. And for tan 10 degrees, we will get 0.18 to two significant figures. For question 4, 5, and 6, we can see we need to change the setup to the angle of radians. So we have sine 1 radian is going to give us 0.84. Cosine 1 is going to give us 0.54. And tan 1 is going to give us 1.6 to two significant figures. Now for question 7, we need to work out the angle of theta. So we can start by writing SOHCAHTOA, which is abbreviation for sine theta is equal to opposite divided by hypotenuse, and CA stands for cos theta equals adjacent divided by hypotenuse, and tan theta equals opposite over adjacent. Now, looking at the question, we can label what we have here. We have a 10 at the top, and that's the hypotenuse. So already we can see we will not be using tan theta because there is no hypotenuse in that. And then we have 8, and that's our adjacent because that's next to the angle, and it's the shorter length. And we can see here, therefore, there is no a in sine, so we can cross that out. So we're left with cosine. So we'll write that cosine theta equals adjacent over hypotenuse, which is equal to 8 divided by 10. And then to work out the angle, we'll take the inverse cos, and that will be theta equals inverse cos of 8 divided by 10. Here are some common trigonometric values. For example, let's take theta to be 0, then sine of this value, theta, 0 in this case, is going to give you a value of 0. The cos of 0 is going to give you 0. Tan of 0 is going to give you 0. So these are very common values. If theta is set to 45 degrees, then sine of theta is going to give you 0.7, and so on. You can have a look here in this table for common values. For tan, you can see we get negative infinity, so these values are not possible. If we plot a graph of sine x versus x, this is what we would see. This is a common graph showing sine x as the function of x. So on the y-axis, we have sine x, and on the x-axis, we have x. And you can see what the graph will look like for negative x values. Drawing the graph backwards, we can see what the graph will look like for negative x values. Patterns will repeat themselves as you go along the x-axis. We can see here the origin will be the 0 value of x. If we go along a quarter of a way, we would have 90 degrees. And for another quarter of a way, we will have 180 degrees. And the next is 270. And we would complete the cycle at 360 degrees. Maximum value that sine can take is positive 1, and the minimum would be negative 1. So the sine of the angle is going to give us any number between 1 and negative 1, depending upon the angle. When y is equal to cosine x, we can see the graph looks like this. Drawing the graph along the negative x direction, we can see what the graph will look like. Comparing the graphs, you can see that sine x is cosine x that has been shifted by 90 degrees. Finally, for tan x, we can see this is what the graph will look like. At the values 90 degrees, 270 degrees, and so on, the value tends towards infinity. So you don't actually get any angles. And the value for y can reach up to positive infinity and down to negative infinity. Now pause the video here and attempt this exam question. Now we can label the diagram. We can draw student A throwing the ball, reaching a height of 10 meters, and student B will be over here, and that's 20 meters away. Now the question is asking about the angle, so we can use SOHCAHTOA. You can see here that we have the opposite to the angle and the adjacent to the angle. So we're going to use TOA, which is tan theta equals opposite over adjacent. And we can plug in the values of 10 divided by 20, which is equal to a half. Then we're going to inverse tan to get our theta, which is inverse tan a half, which will give us an angle of 27 degrees to two significant figures. And that's the end of the lesson. If you would like to boost your grades and try some quiz questions, why don't you visit us at btecrevision.com. See you next time.